Good morning, students. Today we are going to see about electromagnetic fields. As the name says, it is a combination of electric and magnetic field. So today we start with static electric field. We know that there are two types of charges. One is having positive charge, another one is negative charge. Right? So charges comprise to form electric field. So what we are going to see is today the relation between the charges and what is the force generated by the charges and so on. Okay? So these are all stated by Coulomb's law. So we know that every charge exerts force on another charge or another particle, right? When we place a positive and negative charge, they both attract each other. And when we put same charges, it will repel each other. So positive and negative charge attracts and same charges repel each other. Right? So now we are going to see a formula given by Coulomb's. It states that how much amount of force is exerted by a charge. Right? The formula is given by F is directly proportional to product of the charges and inversely proportional to the square of the distance between them. Let the distance be capital R between charge 1 and 2. Let it be charge 1, then let this be charge 2. So what is the force? Force is directly proportional to the product of these two charges and it is inversely proportional to the distance between them. Right? So it is clear that if you want to increase the amount of force, you have to increase the charge, or if you reduce the spacing between two charges, the force will increase. Okay. So we are replacing that by a constant, that is 1 by 4 pi epsilon. Epsilon, we know epsilon is equal to epsilon naught into epsilon r, and epsilon naught is 8.854 into 10 power minus 12, and epsilon r is relative permittivity. So let us take an example. We have a charge q1 and we have a charge q2. It is separated by a distance. In this case, let us assume charge 1 is exerting force on charge 2. Charge 1 is exerting force on charge 2. So my question is, what is the amount of force exerted on the charge 2 by charge 1? If you take the formula, force is equal to q1 q2 by 4 pi epsilon r square. That we know. But here, I need a direction, right? Since my case states that q1 is exerting force on q2, some force is exerted from q1 to q2. If I say like that, direction also comes into matter, right? In similar way, I can say q2 is exerting force on q1, right? If q2 is exerting force on q1 and q1 is exerting force on q2, both forces are in opposite direction, right? So here comes the play. Since direction got involved, the vector comes into play, right? We know what is vector. It is a combination of scalar and direction. Right? So magnitude and direction combine to form a vector. Right? So I need to add a direction component. Let that component be AR. Let it be 1 to, say it denotes 1 to 2. Force is from 1 to 2. Okay? And now we know this name of the component. It is nothing but unit vector. Unit vector. Unit vector is nothing but, if you say a vector, for example, AB vector, it is represented by magnitude of vector and direction of the vector. right? So we know vector is nothing but magnitude and direction. So this component denotes magnitude and this component denotes direction. So if you find this direction component, which is nothing but unit vector, we call it as what will be the formula? Given vector by modulus of that vector. So this we call it as unit vector. So we need to add this component also into this equation, right? You will see problems related with that. Okay, we will solve a problem for that. Problem number 1, right? We have a point charge of magnitude 0.7 millicoulomb situated at 2,3,6, and another charge which has magnitude 4.9 microcoulomb situated at the origin. Calculate the amount of force exerted on 0.7 millicoulomb of charge by another charge. So I will repeat it once again. We have two charges. One is 0.7 millicoulomb and another charge with magnitude 4.9 microcoulomb. One is situated at 2,3,6, another one at origin. So when we say 2,3,6, this is nothing but x, y, z. So 2 corresponds to x, 3 corresponds to y, and 6 corresponds to z. So as the question says, what is the force exerted on 0.7 millicoulomb of charge? It shows that 4.9 microcoulomb is exerting force on 0.7 millicoulomb of charge. Right? So let us assume this is charge 1 and let this be charge 2. So as per the formula, the force is starting from 2 and ending in 1. So let us denote it as F21. The formula says it is the multiplication of the magnitude of charges divided by the square of the distance between. What is the distance? Distance from 2 to 1 square. And direction is very important. It is also from 2 to 1. Okay. We have to find all these values. You substitute, everything will be over. Fine. So first thing is you want to find this unit vector AR21. We know the formula. It is nothing but R21 vector divided by modulus of R21 vector. So the next topic is how to find R21 vector. Vector is always denoted by ending point minus starting point, right? So this is the starting point where the force is starting. This is the force where it is being applied. So this is the starting point, this is the ending point. So how to write? So ending point minus starting point. So in x 2, here x is 0. So 2 minus 0 ax cap plus 3 minus 0 ay cap and 6 minus 0 az. So final answer will be 2ax plus 3ay plus 6az. This is vector. How to find modulus of this vector? Root of 2 square plus 3 square plus 6 square. So root 49. Okay. Now we substitute all these things in this formula. What is the formula? Q1. What is the formula? What is the value for Q1? 0.7 millicoulomb. So 0.7 into 10 power minus 3 multiplied by Q2 4.9 microcoulomb. So 4.9 into 10 power minus 6 divided by 4 pi. What is epsilon? 8.854 into 10 power minus 12. We always assume epsilon r is 1 until and unless it is given, right? Then R21 square. What is R21 square? R21 is root 49. So square is 49 multiplied by unit vector. What is unit vector? The given vector, that is given vector is nothing but 2ax plus 3ay plus 6az divided by root 49. So if we simplify all these terms, we will be getting F21 vector will be equal to 0.17 ax plus 0.26 ay plus 0.53 az. Right? Hope you understood this problem. Suppose if we have more than two charges, let us assume we have another one charge. It is 3 microcoulomb. It is at 1, 2, 3. It is also exerting force on 0.7. Let us assume like that. So now the equation becomes total force will be equal to let us assume this is Q3. So there are two charge forces, right? One is from 2 to 1. So 2 to 1 and another is from 3 to 1. Similarly, we have to find from 2 to 1 we have already found it. Okay. Similarly, we have to find it for 3 to 1 and add up all these forces to form the final force. Okay. Hope you have understood this problem. We will go for next thing. Okay. Okay. Now we are going to see about electric field. Electric field is denoted by E. E is nothing but force divided by charge. So again, I am assuming two charges. Now I am going to find what is the electric field at charge Q2. Q1 is exerting force on Q2, right? Now I am going to find what is the electric field at Q2. The formula becomes, we know E equal to F by Q. Right? We know the formula for F, right? Since force is from 1 to 2, formula becomes Q1 Q2 by 4 pi epsilon R12 square AR12 cap divided by Q. Q is the thing, but where we want to find electric field, right? I am going to find electric field at the place of Q2. So I am dividing by Q2. So if I divide this whole term by Q2, Q2 and Q2 will get cancelled. So electric field equation will become F equal to Q1 by 4 pi epsilon R12 square AR12 cap. Okay. So if we compare force and electric field, there is similarities. If you divide force by Q, we will be getting electric field, right? We will see another one example for this electric field. I will solve another one question. Okay. Okay. Find electric field at origin due to a charge of 10 power minus 8 coulomb located at 0, 4, 4. Okay. And another charge of magnitude minus 0.5 into 10 power minus 8 located at 4, 0, 2. I am going to find E vector at origin. Since origin I know E vector at origin means 0, 0, 0. Right? So I am going to find E vector at the origin. So the force is from these two charges towards the origin, right? Let us assume this as Q1 and this be Q2. Let this be P point. So electric field here, two charges, right? So electric field is due to charge 1 and electric field due to charge 2. If we add up these two, we'll be getting the final electric field. Okay, total electric field. So we'll solve one by one. E1P. E1P is nothing but this is the force exerted by charge 1 to that origin point. Okay. So we'll compute. Formula is the given charge Q1 divided by 4 pi epsilon R, this distance, right? R1 square AR1 cap plus the second, right? So Q2 by 4 pi epsilon R2 square AR2 cap. Okay. We know what is R1. What is R1? Ending point minus starting point, right? So since the vector is from charge to point, this is the starting point, this is the ending point. So if we compute R1, ending point minus starting point, so minus 4 AX 0 minus 0 0 minus 2 AZ, right? Similarly, if you calculate for this R2, vector will be equal to ending point minus starting point, right? 0 minus 0 0 minus 4 AY minus 4 AZ, right? If I find AR1 cap, the given vector 4AX minus 2AZ divided by modulus of 4 square plus 2 square. For this case, AR2 cap will be equal to minus 4AY minus 4AZ divided by root of 4 square plus 4 square. We substitute all these things in the final equation. E is equal to Q1. What is Q1? Minus 0.5 into 10 power minus 8 divided by 4 pi. Epsilon is 8.854 into 10 power minus 12 multiplied by R1 square. R1 square is nothing but 16 plus 4, 20. 20 square is, root of 20 is 20. Right? Multiplied by minus 4 AX minus 2 AZ divided by root 20 plus, now the second term Q2 we know it is 10 power minus 8 divided by 4 pi into 8.854 into 10 power minus 12 multiplied by root 32. Square is 32 multiplied by minus 4 AY minus 4 AZ divided by root 32. If we solve all this, we will be getting a final result. E vector is equal to 2AX minus 1.98 AY minus 0.98 AZ. So let us go through it once again. There are two charges which is exerting force on a particular point. If two charges are there, we have to find it two times, right? So force due to charge 1 on P and force due to charge 2 on P. Okay. Then you have to find it separately and add to find the final value. Okay. So the problems which are related with force is very similar to solve for force as well as electric field. So both problems are very similar. We'll see the next topic. The next topic we are going to discuss is charge distribution. Right? Till now we have seen charge as a point charge, right? Q1, Q2, we are saying like that, point charges. In real situations, most of the real time, charges won't exist as individual charges. They are in group of charges, or you can say it is distributed. Charge is distributed. Let us take a line of length L. So there are so many charges there. Let the total charge be Q. Here Q is not an individual charge, it is a total of all the charges. Right? Now, this Q charge is distributed throughout the length of a line L. Okay. So it is denoted by charge distribution, right? Rho L equal to total charge by length of the line. Okay. So rho L we can call it as charge density, right? Amount of charges divided by length of the line, right? We call it as charge density. Charge density. In similar way, we can take a surface of area AS, right? If we find charge density in this, we denote it by rho S, which is nothing but total charge divided by area of the charge, right? So this is also charge density, right? Charge density. We name it as line charge density, and let this be surface charge density. In similar way, you take a volume. Let the volume of this cube be V. Let us assume charge just distributed in that volume. So charge density, volume charge density is nothing but Q by P. So in particular, if we take a line of length L, let the charge be Q, the total charge be Q. Right? We know rho L, line charge density is nothing but Q by L. In this case, what I am going to do is, instead of taking the whole length, I am taking a small length, right? Let that length be dl, a differential length, right? The charge which are present in that dl is dq. Total charge is q and total length is l. We are taking a small length, that is differential length. The charge present in that differential length is dq, right? So the equation becomes rho L equal to dq divided by dl. If you multiply, dq is equal to rho L into dl. What is q? Q is nothing but integral of rho L dl. Right? In similar way, we can calculate it for surface charge as well as volume charge. And from this equation itself, we can write q is nothing but rho S ds, and for this volume case, this is rho V d. This is distribution of charges, right? Now we are going to see some derivations where charges are distributed in line or surface or volume in different shapes, right? So we are going to solve it by one, and we have to find the equation of electric field intensity or force which are present due to that charge distribution. Okay, so let us start.